Good morning, and many thanks for joining this webinar being run by the Institute for Manufacturing on Total Information Risk Management. I am Jim Truman. I am your host for the day, and during this webinar we will look at an approach researched and developed within the Institute for Manufacturing for quantifying the business value of high quality data and the risks of poor quality data. This approach is all based on risk management techniques and provides a good method of building a business case for data quality improvement programs. So I'm joined today by Dr. Ajit Parlikad and Dr. Philip Woodall. Ajit is a senior lecturer in industrial systems at the IFM. Ajit's research focuses on assets management and how information can be exploited to improve asset value. Phil is a senior research associate in the IFM, specialising in data management, data quality, and big data applications in manufacturing. I'm a principal industrial fellow, and my role here is to take the research that is generated within the Institute for Manufacturing and help public and private organisations to implement that research within their own organisation. So just two quick pieces of housekeeping before we move on to the agenda. First of all, the session is being recorded and will be available online in the next couple of days. And the second part is we will be taking questions at the end, so there will be a question and answer sessions. We are sharing a number of applications today, so if you're unfamiliar with WebEx, if you wish to ask a question, there is a green tab at the top of your screen, and on there is a questions tab. You go into there and type in your question. Please address it to all panelists so that it comes through to the right team here at IFM. So a very quick note on the agenda. We expect to run through to shortly before 10:45 this morning. And we'll be going through a very brief introduction to the Institute for Manufacturing. I'll be passing on to Ajit, who will be going through the problem associated with quantifying the risk of poor quality data. Ajit will then also talk through the answers according to our research, so talk through total information risk management. And then we'll pass over to Phil, who will go through a couple of case studies of how we've applied TIRM to quantify some of those data issues. We'll then move on to questions and answers and then wrap up. So very briefly, the Institute for Manufacturing, for those people who have not come across us before. The Institute is part of the Department of Engineering at the University of Cambridge, and we focus on research and education into all aspects of modern manufacturing. Through that, we maintain very close connections to both industry and government, and there's a number of practitioners, such as myself, that apply the research from within the Institute with a view to both providing feedback into researchers and also to provide additional funding streams for that research. We take a very broad view of manufacturing, so it's not just the art of making things. The different research centres within the Institute look at all elements of industrial system design, so all elements of industrial systems, including design, innovation technology management, servitization, and government policy. And total information risk management is one example of an element of research that applies equally to utilities, retail or service organisations, as well as traditional manufacturers. So I'm going to pass over to Ajit, who will talk you through, first of all, the problem.
Thank you, Jim. Good morning again. As Jim mentioned, the topic for the day is data quality. So to start off, I'll quickly provide you with some brief background on the problem and then set out the questions that you might want some answers to, followed by a description of the research outputs that we have here at the Institute for Manufacturing that helps you answer those questions. Then I'll hand over to Phil to take you through a case study. So this is something we are all familiar with. We are living in a digital age now. There's increasing amount of data that we keep collecting about our processes, about our assets, about people, our customers, and so on. We hear about social networks and how companies use the data that is being shared by people across the social networks to build profiles of people and understand our customers better and so on. There's a lot of buzz about big data and predictive analytics and how you can use data to improve your business processes. But on the other hand, we face problems such as these. So you might have a utility company, and some of you are from utility companies, and this might be a common problem for you. You have errors in meter readings, for example, errors in customer databases, which results in incorrect bills sent to customers, and customers losing confidence in companies' performance, which leads to finally then companies getting slapped by fines from the regulator, customers leaving to their competitors, and so on. If you take another example, you could see supermarkets. They might be holding data about their inventory, stock levels, and so on. And if there are errors in the inventory data or errors in the supplier databases, that could result in stockouts and lost sales, and ultimately customers might leave to their competitors as well. So what we can see here is, although information provides you with that competitive advantage, if you don't handle information properly, if the information that you have is of poor quality, this will have a direct adverse impact on your business performance. So this is the problem that we are going to tackle in this talk. And now companies facing these problems would have come up with a lot of solutions. They might think of installing new information systems, new sensors, or providing training for their people to get better quality data, and so on. But each of these solutions that you come up with will have a cost associated with it. And when you bring these solutions to your senior managers or your executives and ask for funding for these information quality improvement projects, they are going to want to see a business case for it. They want to see a return on investment that you're going to make in these new systems. So some of the questions that you'll have to answer to build the business case is, okay, we know that we have poor quality data, but what impact does it have on my business? Now, you might have lots of problems with poor quality data in your organization, and you'll have lots of solutions for it. How do I prioritize these projects? Which one should I do first and next, and so on? And is it actually worth investing in new systems and technologies? So these are the key questions that our methodology will help you answer. And the key to answering these questions is to understand that poor quality data actually poses a risk to your organization in terms of affecting your business objectives. So your business objectives could be good financial performance, satisfying your customers, complying with health and safety regulations, and so on. And the key to answering these questions is to understand how poor quality data affects those business objectives. So what have we done here in Cambridge? We went through a 3-year research program funded by the UK government, and we came up with this risk-based approach to information quality management. So understanding the risks posed by poor quality data and quantifying them and using that to help build a business case. The important thing to note about this concept and this methodology is that it is based on well-established concepts such as ISO 31000 for risk management, other techniques such as failure mode and effect analysis, root cause analysis, and so on, which means that using the methodology we have developed in your organization should be quite straightforward if you are familiar with these already well-established concepts. The key thing here is that the methodology has been developed by testing and refining extensively in a number of industrial organizations that you can see there. So a special thanks goes to all these companies because without their help we wouldn't be able to develop this method. I should also add that the work has been, a lot of this work has been done by one of my PhD students, Alexander Borek, who finished his research a couple of years ago, and he's working with IBM at the moment. So thanks goes to him and the companies who have supported this work. So what is it that we have done? So to answer the questions that I've posed earlier, we have developed a structured process to ask to get answers to the questions, and this structured process is supported by a rigorous mathematical model, as you can see on the right-hand side. So what is this process for answering the questions? So first of all, we'll go through the model, and then we'll go through the questions. So as you can see here, this is the outline of the model that we have developed. So on the left-hand side, we start off with the business processes in the organization, and on the far right-hand side, you've got your business objectives. So what we are looking at here is, for each of your business processes, how is poor quality data affecting those business objectives at the end? So, for example, you might have a supply chain management process which involves a number of tasks, and one of them might be selecting the right supplier for a particular task, and you might be using information on the reliability of those suppliers in order to select the right supplier. And the problem you might be facing is that you don't have sufficient data about your suppliers. So that's the information quality problem that you face. And this information quality problem, say, if you need to select a supplier and if you don't have the right kind of data about your supplier, you might end up choosing the wrong supplier for that particular task, which might lead to, say, for example, if the wrong supplier in terms of if the supplier is of poor reliability, you might have supplier delays and products getting delivered late, which might in the end affect your customer satisfaction. So that's the chain of events that we try to capture in our process and quantify using the impact that each of these consequences have and the probability of occurring these consequences occurring as well. So that's a mathematical model which underpins the process that we have developed. This is a snapshot of a broader range of business processes, tasks, data that you might be using, the data quality problems that you might face, and the consequences that you might face due to poor data quality in a particular organization. So what is the process? So the total information risk management process, it's broadly categorized into 3 phases. The first phase is about establishing the context. So understanding the problem, understanding the business environment, understanding the business objectives of the company, understanding what information systems and technologies and people are in use in that organization. This is followed by an information risk assessment phase, which is essentially going through that mathematical model that I showed you earlier, identifying the business processes, the tasks, the information used in those tasks, the quality problems that you have with that information, finally ending up with a calculation of the total risk posed by the information quality problems on your business objectives. We end that phase by evaluating those risks and prioritizing those risks in an ordered fashion. From that prioritized list, we will then select the top risks that you're facing and select them for information risk treatment. So this is where you say, okay, we have identified the key problems. How do we actually solve these problems? So here, the first step is to go through a root cause analysis and say, okay, if you have incomplete data in your database, why do we have incomplete data in your database? Once we identify the root cause, we can then start identifying potential solutions to those problems. This could be technological solutions by, say, for example, getting new systems in place, or other people-related solutions such as providing training as well. So once we have those solutions, we then re-evaluate what are the residual risks then posed by the solutions, and then evaluate the cost-benefit analysis. How much does it cost? How much risk does the solution help remove? And that will give you a good estimate of the return on investment for the solutions that you have. You finally finish off by communicating the results to the stakeholders, building the business case, and getting the project going. So that's the process. Now I'll hand over to Phil to take you through an example which will make all these things a bit more clear.
Okay, thank you, Ajit. I'm Phil Woodall, and I'm a researcher here, as Jim mentioned earlier, and I again worked with Ajit on developing this process. I'll take you through a particular case study that we have, and it's based on one of the trials that we did initially to develop the process, but we have changed all of the details to protect confidentiality, and we've changed the numbers that you'll see. So they aren't reflective of a real case, but hopefully it should give you a flavour for how the process works and what the process looks like. I shall take you through the three phases that Ajit talked about, establishing the context being the first one, then the information risk assessment, and then finally move on to treating that risk. And the particular example we're looking at today is a water utility company. And I won't go through all of the details of the process because, as you can see, there are many different sub-stages to this. But I want to give you an overview so that you can see generally what it looks like. So the sorts of tasks and processes you'll be doing within establishing the context would be setting things like the initial motivation for why you want to do this and carry out this process. And in this case, it was to quantify the impact of information risks in a particular area of the business. And that was the water supply recovery area. And the aim of this was to bring any significant risks to the attention of senior managers. And often is the case we've found with this particular process that it's more important for managers who know and understand the problems but can't quantify what the actual risks of those problems are and what the issues are on the bottom line of the organisation, that we quantify those so that senior managers will buy into any improvement activities that you want to do as part of your company to improve those problems. So also within the establish the context, you would be looking at documentation of your existing processes, your existing information systems, and gathering together all of those details so that you're then prepared to do a risk assessment, an information risk assessment. And that is the second process. And I've brought up here the slide that Ajit showed earlier just to reiterate that, because we have a software tool that we use for this particular part of the process, and it's based around this model of going from the business process to the task, to the information used for that task, all the way to the business objectives and the impact on those objectives at the end. So I can actually show you a screenshot of our tool that we use in this particular case. So here it's actually a mind map.
Just while we're checking on that, just to remind you that if you do have any questions, you go to the green tab at the top of your screen and onto the question. So we should now have that up on the screen.
Okay, so this is the first screenshot of the tool, and it's essentially a mind map where we start off at the business process, the network recovery process there on the left-hand side, and in this case, because this is a case, we've only looked at one particular task, whereas you can imagine that within a company and a business unit there will be various different tasks, and you can model that within this tool. But we'll look for this example at the water response and how they fix and repair problems in their supply of water to domestic houses and businesses. And you can see at the next level, after this task that they're performing, they're using two pieces of information, and these may be information systems or they may be different parts within one information system. And we have the asset location and the asset maintenance data, and this asset information about the location would probably be in an asset register of some sort, whereas the maintenance data would be in perhaps a maintenance system. And we can see from then on, for these two pieces of information, we show a particular problem. And so this is an information quality problem where sometimes in the asset maintenance information, we have a missing record, so we cannot find the information about that maintenance for a particular asset. And if we encounter that, then that can lead to an incorrect repair, burst pipes, eventually leading to customer compensation perhaps. And you can see here that we quantify at each stage the chances of this occurring and the frequency with which it occurs. So if we look at the water response task, we can see that typically we get a repair and fix problem occurring between 3,000 and 8,000 times per year. And then, based on when we have a repair problem, we then use the asset maintenance data approximately 90% of the time. So almost all the time we use the asset maintenance data. And the problem is that 50% of the time we encounter a maintenance record that does not exist. So we may not know it exists, which in thinking that the maintenance, or there has been no maintenance. And again, from that, if we encounter a maintenance record or don't find the maintenance record, then there's a 50% chance that we do an incorrect repair, and similarly there's then a 10% chance that we have burst pipes. And eventually that leads to an actual quantification of the impact in terms of pound figures. So here we have a region between 150 and £1,000 compensation that we may pay out. And during the process, to collect these figures, we typically do workshops with the various stakeholders who know about the systems, who carry out the tasks, and who know about the particular problems. And that's typically how the previous studies that we have done with this process have worked. And in some cases, companies already have the documentation for this, and in other cases we need to start with estimates and then build on those. So to show the actual the tool working, we've got another screenshot where we can show the actual results of the simulation, where it calculates the overall risk to the business for this particular process. So I can jump to that particular slide, and here we have the results. So we can see for the asset register information we have a risk of 34,000, and for the maintenance data we have a risk of approximately 66,000, leading to an overall annual risk of about £100,000 for this particular task and all the data and all the problems associated with that. So we can see that there's a confidence interval, and that's because we run a simulation to get these figures. And so it's really more important to look at this 95% confidence interval than it is to look at the exact total annual risk. So we can see that we're between 99,000, 100,000. So that's the important figure to look at. And we get a breakdown per business impact. So in some cases we have a customer impact, and in other cases we have an operational efficiency impact. And if we look at the end of the other stream of consequences and business impacts, we have some customer impacts here, and we have an operational impact in some cases. So it aggregates all of the details together from all of the risks that you have and all of the consequences, and puts these together into this summary here. So if we go back and look at the next stage of the process, after the assessment, and that's to look at the treatment of the risk. And so what might we do to mitigate some of the problems? And if you remember, we had a rather large risk on the maintenance data, which was about double the risk on the asset register data. So we may look at options to incentivize engineers to complete maintenance forms to make sure that that information is complete, or we may initiate data quality assessment improvement programs on the existing maintenance data to correct that existing data as well as new data that comes in. And if we jump back to the demo, the screenshot, again, just wanted to confirm that maintenance data was about double the asset register, so it's double the risk there. So if we look into this stream of maintenance data, we can see that it's quite a high percentage of records that are missing. 50% of the time we have a record that's missing. So we may want to look in a closer detail into that and see if we can apply a treatment to reduce that figure. Let's say we can try and halve that figure. So again, with the tool, we can include that in the simulation. So we can add in a particular risk treatment, and instead of it being 50%, we can now include it to be, say, 25%, if that's what we'd expect to achieve by any improvement program. And then we can run those results to see what effect that does have on our overall risk. So if we look at the final screenshot, we see the actual risk compared to the treatment, the risk after the treatment. And we see we've come down from about £100,000 to £67,000 per year in terms of our risk. And that's because we've, again, halved our maintenance data risk here through doing that program of improving the maintenance data. So you can see how the tool will show you, and the process shows you exactly where to focus and exactly what to look at and what benefits you're likely to yield from that. So again, we may incentivize those engineers to complete those forms so that we have that complete information. We may also have defined procedures for when a maintenance record is not found. Any number of different risk treatments could be considered, and within this process, this gives the actual process has a structured and systematic way of looking at each of these options to see what are the significant problems and then what are the best risk treatment options to use for those. And again, the process takes you through that so that you can achieve the results that you want to, and then demonstrate those, hopefully, to senior managers to show just what a benefit they can have on the business. So overall, the benefits of doing this case study is we have a quantification of the information risks in this particular business area. And we have a clear identification of any significant information risks, and then we can therefore present a strong business case to any senior managers who may sign off on improvement programs. We can also look at the other benefits in particular in this case study, which may be a reduction in customer compensation costs and a benchmark then for future risk assessment, which is quite important, that if you find the process valuable, then it's not a one-off. It doesn't need to be a one-off process that you run. You can run this over time, and if you continue to use that, you then have benchmarks for the future in any risk assessments that you would apply. So overall, the process tells you to treat information as a core asset to the company, and it gives a rigorous and risk-based approach to governing that information. And it shows just how you can prioritize different projects based on a quantified business case, which is well then justified, of course. And overall, it brings a structured and systematic approach to managing your information in the business.
Thank you very much, Phil. Thank you, Ajit, and thank you all for your attention so far. We have a couple of questions which have come in, which I'll ask to Ajit and Phil. I'm looking through these. There's two similar ones here. So first of all, I'll ask you both. In what type of companies or industries have you applied this methodology, and where do you believe that it is relevant?
Okay, so through our research, we have applied this methodology predominantly in asset-intensive industries, such as manufacturing organizations, utility companies, which use very high-value, capital-intensive equipment to deliver their products and services. That is where it has been tested. But as you could see in the presentation, there is nothing that actually limits the application of this process to such industries. So we believe that the same process can be used to identify and quantify risks in poor quality data in other types of organizations like banking and other services type of organizations as well. So the assumption is that the application range is quite wide for this process.
Thank you, Ajit. Second question here. The processes from Phil's explanation seems to be quite data heavy and time consuming. Could you give us an idea of the typical length of time and resource that this sort of study or project would take?
Yeah, that's a very good question. The length of a TIRM project, if you will, it really depends on the scale of the problem and the scale of the organization as well. Predominantly, as you can see, a clear calculation of the risks takes a lot of data as input for this calculation. It might require us to talk to several people in the organization. So it depends on how many people we will need to talk to, whether we can get all those people together in time and so on. That determines the length of the process. But typically, from our experience, this takes roughly 2 to 3 weeks, a week each for each of the phase of the activity. And that is for a medium-sized organization. So depending on the size and the people that we talk to, the time taken would be different.
Okay, thank you. And another question, how do you see the software product developing over the next few years, and will it become commercially available?
Excellent. So the software product that we have developed is essentially as part of our research project. It's a research quality, we can say it's a research quality software product. It is not in a form that can be sold commercially to organizations. It is predominantly designed to support any projects that we might run for companies like yourself, and support our consulting activity in terms of helping us calculate the risks and so on. But as Jim mentioned, one of the primary objectives of the IFM ECS is to run such projects with companies and to provide the research centers with some money to carry out further research in these areas. So what we see is, to start off with, this software product will be used by ourselves to run these projects, and as funding comes through our projects, we will refine this software product in such a way that it can be actually commercially made available to anyone who wants to use it.
Thank you, Ajit. I'll move on to a final slide, really, which is around further information available on total information risk management, and two aspects to this, really. So one is that if you are looking for further support or more information on TIRM, then first of all there is a book which has been written by Ajit and Phil and Alex, which is available on Amazon. So if you go onto Amazon and search Total Information Risk Management, you will hopefully be pointed at that book there. And secondly, as we've said a couple of times, we do have a team of practitioners, myself included, who are able to work with organisations in providing information risk assessments, work with projects within your organisation to progress those. So if you're interested in that, my details are there, or we will send out further information pointing towards the online recording later. You can always come back to us then. So hopefully the session today has given you a good insight into TIRM. Many thanks for your attention over the last 40 minutes or so. If you do have any requests for more information or would like a further conversation, don't hesitate to get in touch, and we look forward to working with you all soon. Many thanks, and thanks to Phil and Ajit.
Thanks to all for joining this webinar.
Thank you.